Hello and welcome to the fourth video of Module 3. All right, we left off with the DHCP. Okay, the reminder, don't forget to take your notes and submit them when we're done. All right, so when we're talking about the DHCP, don't forget the DORA, the D-O-R-A, the 4 handshaking signals that the DHCP will happen before the client and the server, before the server gives the client the IP configuration. DHCP discover from the client, then the DHCP offer from the server, then the DHCP request, and then the DHCP acknowledgement, right? And then the server will give all the information that it needs to the user. All right, the DHCP attacks, which we discussed in the LAN security in the previous course. You got the DHCP spoofing attack. Please write those down. Wrong default gateway you can do. Wrong DNS server information that you can also give out, wrong IP addresses. So if you can poison the DHCP server and get to it, you can do all of that. Or pretend to be a DHCP server, right? So what you need to worry about is the CIA. Remember that? Please write those down. Confidentiality, availability, and integrity. The defense in depth approach includes, okay, well, before we get to that, I want to discuss the CIA first. Confidentiality, meaning only specific users are allowed, or authorized users are allowed to see the data. And therefore, to protect the confidentiality of the data must be encrypted. Integrity is to make sure that data has not been tampered with while it's in transit, or it has not been corrupted. So how do you protect the integrity of the data? You use a hashing program. And the availability of the data. Make sure that users have access to their resources whenever they need to. So redundancy is extremely important. Have redundant gateways, redundant switches, redundant links, and we've been discussing that in this course and in the previous course, right? So that's important. So you gotta, every day as a security officer, you need to think about the CIA, the confidentiality, integrity, and the availability of the data. All right, to be able to do that, you want to use a defense in depth approach. The defense in depth approach will include, write these down, VPNs, ASA firewalls, IPSs, ESA, WSA, and the AAA servers. Okay? So you need to, and another thing, you need to harden the routers and the switches and secure data as it traverses over the network. What I mean by that is, of course, having a firewall. All right. So firewalls are like security guards. Now, we've been discussing that when we discussed ACLs, right? That either permits or denies traffic according to a list, an access list. You can buy its own appliance, or you can have the router. If you have a small enough network, you can use the router to act as a firewall. But if your network is large, it's probably preferable that you have a separate appliance for that. IPSs, the intrusion prevention systems, is the ones that are being, they detect attacks, denial of service attacks, for example, depending on, on their signatures or on their anomalies. Whatever. So you have to tune in your IPS systems to find out if there is an attack or not, and you can stop it. Intrusion prevention system will sit in front of a firewall, for example, and if it sees an attack, it will stop it right there. There's another thing called intrusion detection system, IDSs, which is no longer being used. That's usually placed inside the LAN that you're trying to detect an attack and then tell the firewall to stop it. But the problem with that is, once you detect an attack, because it's already in the LAN, so you probably don't want to deal with that. Most users usually use IPSs. All right, so that's where you place an IPS, is you're trying to detect and drop the packet if you see that there's an attack. All right, then you got the EPSs. What do we got here? You got the ENSA, the email security, and the WSA. Okay, we talked about that in the previous course. the web security appliance as well. Now let's talk about cryptography. Cryptography is the science behind encrypting or scrambling the data. All right. So when it comes to the 4 elements to secure communications: data integrity, origin authentication, data confidentiality, and data non-repudiation. Just please write these down. If you want to write the definition, that's fine, but at least you need to know the 4 elements of secure communication. Again, data security, origin authentication, data confidentiality, and non-repudiation, which says you cannot repute or say, hey, this is not my data. All right. All right, so data integrity. When we're talking about data integrity, it uses hash algorithm. Now, it is vulnerable to man-in-the-middle attack and does not provide security to data transmitted. This is just to make sure that the data has not been tampered with. So if somebody sends you $10 and on the way, you change the 10 to 1,000, you want to be able to know that somebody tampered with it and changed the 100 to 1,000, and you can drop it. And add. So that's what authentication does. All right. Sometimes, you can encrypt it if you want, but that's what the hashing does. It's going to make sure that you know that the check that's you being sent has not been tampered or changed. That's what hashing does. Hash programs that we got the MD5, the message digest number 5, that's being used, for example, when we do the enable secret password. Enable secret is hashed using the MD5. You got the SHA algorithm, the secured hashing algorithm. There's 1, 2, there's the 256. These are very strong and mainly used when you're doing VPNs. And maybe we'll do a lab on that in class on how to set up it when we do the VPN later on this semester. Then you got the HMAC. So what you do is you take your hash and you encrypt it with a key. So when you send it, and what you do is if the guy, which we'll discuss later on, if you are able to decrypt, you have a key that you're going to decrypt the hash. You don't just send the hash in plain, because somebody can change the numbers in the hash, and you'll always have the wrong, the integrity of the data will be corrupted. You will be always dropping the packets because you always think that the data have been tampered with. So what you do, you take the hash and you encrypt it with a key. And when you receive it, you're going to decrypt the hash with the key, get the hash, and then you run and try to find if the data has been tampered with or not. So that's what HMAC is. All right, so HMAC is calculated using a cryptographic algorithm that combines a cryptographic hash function with a secret key to defeat the man-in-the-middle attack, of course. All right, now looking at data confidentiality. There are 2 classes of data confidentiality, and they are different. Please write these down. There is symmetric and asymmetric, right? So please write these down. Symmetric, we have the DES, the data encryption standard, and the triple data encryption standard, and we got the AES. This is the latest and the greatest. In asymmetric algorithm, you got the RSA. This is when we do SSH, where you actually use an asymmetric, which we'll explain, and the key infrastructure for VPNs. Okay, symmetric is always better than asymmetric. Symmetrical is much faster, I should say, not better. Much faster. Sometimes it could be 1,000 times faster if it's in software. If it's in hardware. In software, it could be 100 times faster. All right, so symmetric key means you have in the same keys on both sides. You encrypt and decrypt the data with the same key. Makes it much easier. But that's, of course, that's vulnerable for attacks. So that's why you constantly got to keep changing the keys in a VPN. All right, and 2 problems with that. You want to keep changing the key. And the other problem with symmetric keying is how do you get the key to the other guy on the other side in a secured manner? So what we do, we use asymmetric to do that. All right. But that's much quicker when you encrypt and decrypt the data using the same key. Like I said, 10 times faster. Please take a snapshot of this. This is going to show you all the different types of symmetric encryptions that are out there. We got the DES, the triple DES, the AES, then you got the SEAL and the Rivest ciphers. Ron Rivest created, he's a big guy. He did everything. There's 6 of them. RC4 is used for WEP. It's also used for SSL. RC6 was in competition with the AES, where the U.S. government wanted to use, those encryption methods for their data, and they went with AES instead of RC6. And our AES, of course, now is what's recommended for you use. It's part of the WPA2 encryption for wireless signals. Triple DES still hasn't been cracked either. This is where you encrypt the data with one key, decrypt it with another key, and then encrypt it again with another key, right? 3 different keys that you use. Still very difficult to crack. Asymmetric is when you create 2 keys. And if you encrypt the data with one, you have to decrypt it with the other, okay? So what I do is I'll create 2 keys. I'll keep one. That's called a private key. And I'll give everybody that wants to communicate with me in a secured manner the other key, called the public key. So whenever you want to send me data, you'll encrypt the data with the public key and send it to me. Now, if somebody captures it on the way and they decrypt it with another public key that I gave out, they can't, because the only person that can decrypt it is with the other key, the one that I kept and I did not share with anyone, the private one. All right, so that's a very secured manner. And for non-repudiation, by the way, if I say to you guys, for example, we're going to have next week off, so when I send a message and I encrypt it with my private key and I send it to everyone, if you were able to decrypt it with your public key because you have the other key, then it's legit, right? It has to come from me. That's non-repudiation. I cannot say, hey, I didn't send it, because the only reason that you were able to decrypt the data is because I must have used the other key to encrypt it, right? So it's very powerful, but it takes a long time, and the keys are very, very long to do that. So we'll use these keys to transfer, we'll use asymmetric encryption to transfer symmetric keys in a VPN, all right? So just to set us up, and once that's set up, once we get their symmetric keys, we'll use symmetric keys over a VPN for a certain amount of time, and then we'll ask the asymmetric to send us another key in a secured manner, and then we'll use that for a certain amount of time, and that's how it works, right? And here are examples of the protocols of asymmetric key algorithm. Please write these down. This is the Internet Key Exchange that's used for VPNs, IPsec VPNs. Again, we'll try to set something up in lab doing that. It's used for SSL. Every time you type HTTPS, we're using SSH, that's the RSA, asymmetric keying, and pretty good privacy. That's when you're encrypting emails as well. All right, and here are the different flavors of asymmetric encryptions. So please write those down as well. So you got all of these different types. DiffieHellman is what's used to transfer the symmetric key in a VPN, right? So take a snapshot of this. We'll discuss some of this in class 2. The DiffieHellman is DH1, DH2, DH3, and so on. All right, and this is a good example, so please read this. Take a snapshot of this. All right, this is like when you agree on the same color, then this is the secret color, and you mix, you pass the mix to each other. Ultimately, you'll get the same key. That's how you pass keys across. All right, so that's it. We're finally finished with Module 4. Please write everything that I asked you to write up and submit it as homework, and I'll see you on Module 4.